Hello. In this lesson, I would like to do a summary and use this time to review what we have done so far. So far, we have covered sine. Well, we have covered the general definition, right? We have covered the general definition of trig functions. And in particular, we covered sine curve, cosine curve, arc sine curve, and arc cosine curve. We had a very detailed discussions about, in the cases of special angles, right? But what is the relation between a special angles or special terminals versus just any angle or any terminal, right? So what is the relationship? So in this discussion, we're going to recapture those moments in the past so we can have a clear view about what we have been doing for the past few weeks. Now, we have started with a definition of function, right? We talk about a function is a rule, right? A function is a rule that satisfies specific conditions, which is specified by that, right? So this rule needs to assign each input exactly one output. So this is the requirement for a rule to be called a function. And we have discussed many rules before we reach this, before we reach the trig functions. And then when we talk about trig functions, we have a stage set. We talk about what is standard position, right? So all inputs to the 6 trig functions are measured from the standard position. So what is standard position? Well, standard position is the positive direction of x-axis. As we are very familiar with, okay, to the point that we're taking it for granted. And so this is the this is a standard position. This is the standard position, right? So we make sure we understand that. Okay, so I'm going to put it right here, the standard position. And sometimes I use different colors just for the illustrations purposes, right? And the next important concept is how angles are measured. How angles are measured, right? Positive angles are measured counterclockwise from the standard position. The negative angles are measured clockwise from the standard position. So if you see if you're given any angle, right, you're told that this is a positive angle. There's a positive sign with no sign in front of it, then you know this angle is measured from the standard position counterclockwise. If you're given an angle that there's a negative sign in front of the number, whether it's a radian or degree, and you will know automatically that this angle is measured clockwise from the standard position. Reference angle. We emphasize this concept over and over again because they have such an important role in our study. So reference angle is the positive acute angle. Positive acute angle. Acute angle means that the angle is between 0 and 90 degrees, with 0 to pi over 2 in radians between terminal and x-axis. So that's reference angle. In the definition, right? After we set the stage, we have standard position, we have angle measurement, rules being set up, reference angles. Now we introduce definition. In the definition, we say that A is an angle in standard position, which means it's measured from standard position, right? Positive direction of x-axis, either counterclockwise or clockwise, any way you wish. And a point on terminal side of the angle other than the origin. And this point, as long as it is not on the origin, any point will do. Any point will do, okay? Because it didn't have any requirement regarding this point, except for it cannot be origin, right? So what does this condition imply? The point on the terminal side of angle other than the origin. So what does this point imply? This point implies that because it cannot be origin, that means x and y cannot be 0 at the same time. As a result, r must be positive, right? So we put a note here. So r is always positive. R is always positive. As a consequence that when we anywhere we divide by r, anywhere we have r as a denominator, and these will be guaranteed, we're not going to have a 0 denominator. Okay, we're not going to have 0 as a denominator. However, x could be 0, y could be 0. So tangent could have a 0 as a denominator case, which we have to take care, and the cotangent and the cosecant and secant too, right? We didn't say x cannot be 0, y cannot be 0. Well, x can be 0, y can be 0, because it is a point on the terminal side of the angle other than the origin. So we simply just guaranteed r is going to be positive. So that's a definition. That's a definition. From the beginning, we have talked about the topics of y unit circle, y unit circle. So here, we're going to talk about y unit circle again. So I'm going to give you some more details about this analysis. So this is about the third time in my recorded lecture to talk about this, right? Y unit circle. Because we have seen so many advantages, right, of having unit circle, of having, we have done much study. So in this regard, right, what I would do is that assuming we pick 2 points on the terminal, pick 2 points on the terminal, x1, y1, x2, y2, right? x1, y1, x2, y2, they are the points, right? They are the points. If A is an angle other than, this is an angle from in standard position, right? So we basically choose 2 points, 2 points, okay? So we chosen 2 points. For the first point, right? We choose x sub 1 and y sub 1 on the terminal side of angle other than the origin. So R1, okay, we'll have an R1, Y1. Okay, so X1, Y1 is a point on the terminal sides of A other than the origin. So we use a narrative and then we'll put a definition together, sine, cosine. So everything is, related to x1, y1, r1. And then we choose another point, okay, another point, which is x2, y2. And this time we have r2. We have r2. Okay, so this is x2, y2. For x2, i2, r2, we got another set of ratio, sine ratio, cosine ratio, tangent, and so on and so forth. So for x1, y1, we got r1, right? So we get a set of ratio. For x2, y2, on terminal side of the angle other than the origin, we get another set of ratio. The question is, are these ratio the same? Right? Because they are done for the same angle. They're done for the same angle, right? So let me bring this picture over here, right? Let me bring this picture over here. looking at sine, cosine, for example, right? Sine, we have y1 over r1. Sine A equals y2 over r2. We have picked 2 points. If they give us a different ratio, then we're in trouble, because if that means sine cannot be a function. Why? Because for each input, there should be exactly one output. So we must guarantee that these two give us the same number. Okay? Is that true? Is that true? That's the question. Okay? So now let's see if that is true. Okay? So we're going to take this picture and we want to see, is it true? Okay, so we bring the picture over here. Okay. What do we see here? What do we see here? That we see 2 triangles. We see 2 triangles. Okay, so what are these 2 triangles? The first triangle, okay, the first triangle, let me make a table. Let me make a little table, okay, so we can have a, you know, comparison. We can have a comparison, okay, systematic comparison. One more row. Okay, so I think three columns should be sufficient. Okay, the 2 triangles are the 2 triangles are, the first triangle is the small one, OPS. OPS. Do you guys see the P? Let me make sure you see the P properly. Do we see the P? It's very slow. Okay, so that's a P. Okay, so let me make just a little bit adjustment for that P to be more visible. Okay, so let's make it Q. Okay, the first triangle is, I'm going to use a symbol, right? I'm going to use the symbol. You probably have seen this before. The triangle OPS. OPS. And there's another triangle. There's another triangle. The other triangle is OQR. Okay, so the other triangle is OQR. Okay, so one is a small triangle and the other one is a larger one. We look at these 2 triangles, they certainly have O as their common angle, right? You see SOP and ROQ, right? The angle, okay, I should find a symbol for the angle. Symbol for angle. I'm sure we have it. Right here. Okay, wait. Let me use the other one. Okay. The angle SOP, and the other angle ROQ. Okay, the angle ROQ. ROQ. They're the same angle. They're the same angle. They're equal. Right? They're equal. What else? The angle OPS, which is a 90-degree angle, and the angle OQR, they're the same angle too. They're 90-degree angle. So the other 2 angles, or the other 2 angles, the corresponding angles, they're the same too. So OPS, angle OPS is the same as angle OQR. OQR. Well, they're both 90-degree angles, right? And of course, the third angles are the same, especially because the two blue lines are parallel to each other, right? And so these two triangles, so let me put on that condition as well, right? So the angle of OSP, okay, OSP and the angle right here, right? ORQ, okay, ORQ, ORQ. These two angles are also the same. So we basically have two triangles that their corresponding angles are the same. Therefore, these two triangles is similar to each other. So this angle is similar to the other triangle. Okay, so these two triangles are similar. As a consequence, what will be the consequence? The consequence is that the corresponding sides are proportional. Of course, the corresponding sides are proportional, okay? So that's the property of respective, that's the properties of similar triangles. So we got a proportional size. So let's see, what are they? Right? So proportional size. So what are these proportional sides? Right? So for example, SP and RQ are corresponding sides. OS and OR are corresponding sides. OP and OQ are corresponding sides, right? So corresponding sides. Okay, look at the sides. So what are the respective sides? OP and OQ are respective sides, right? So OP to OQ, right? Their respective sides. OS and OR, right? So OP, okay, the corresponding size is OQ, right? OQ. What else size? OP and OQ are respective sides, right? OS and OR. OS and OR. Okay? OS and OR. OS and OR. What else? SP and RQ. SP and RQ. SP and RQ. RQ. Let's see, what is OP? OP, let me mark this side with the standard representation, right? So these means line segment. So these lines are respective sides. Okay, corresponding sides. Okay, corresponding sides. So I'm going to mark them so that we all understand what we're talking about. Okay, similar triangles, their respective sides, right? And next, what is OP? OP is x2. OP is x2, right? What is OQ? OQ is x1, right? OS is R1. Okay, OR is R2. Okay, how about SP? SP is Y2. And RQ is Y1. Okay, so we have these respective sides. Okay, we have these respective sides. And then what do we do? SP is Y2, RQ is Y1, SP is y2, RQ is y1, yes. OP is x2, OQ is x1. All right. So now we can formulate our proportions. Right? Now, the first proportion we're going to formulate is that, so all these proportional sides, right? So let me see where should I put it? Maybe next to it. Okay, I'm going to make this just a little bit smaller. Okay, so we have more space. Okay, so here are the proportions. Okay, so here comes the proportions. Okay, one of the proportions will be about this. It's all about size, right? Y1 over R1. Okay, so Y1 over R1, right? Y1, this is Y1 SP, right? Y1. No, Y1 is RQ. Y1 is RQ. R1 is OR, okay? So Y1 over R1, Y1 over R1 should be the same as Y2 over R2. So that should equals to Y2 over R2. They are respective sides. Right? Hypotenuse corresponds to each other, which are the R1 and R2, and Y1 and Y2. So these two are proportional. Y1 over R1 is the same as Y2 over R2. That proportion, what are they? If we take this proportion and go back to see what we did, right? Y1 over R1 is the same as Y2 over R2. They are the same. Therefore, these two proportions give us the same value. Therefore, for the input A, sine ratio is exactly 1. It's unique. Satisfy the function requirement. Okay, let's see x2 over R2, x1 over R1. So we can formulate the next proportion, right? The next proportion will be x1 over x1 over x1 over R1, right? So x sub 1 over R1. x1 over R1. What is x1? What is R1? x1 is OQ. R1 is OR, right? And y2, I'm sorry, x2. x2 is the shorter one, right, from OP. Therefore, this is going to give us x2 over R2, right? And these two are cosine ratios respectively. They are, let me remove this picture. Okay, you see, for cosine, we have x1 over R1 and x2 over R2. And these two ratios are the same as well. Let's look at for tangent, right? Y1, right? Y1 over x1. Y1 over x1. What is y1 over x1? Y1 is RQ, SP, right? So y1 over x1 and y2 over x2. And these proportions are also the same because they're similar triangles. So y2 over what? Over x2. So this tells us the two tangent ratios are the same. These two ratios are the same. And if these two are the same, and then cotangent will be the same, right? You just flip them upside down. You just flip them upside down. So x1 over y1 is going to be the same as x2 over y2. All right. Now we have two more to go. So this shows that sine, this shows sine, hold on, I'm gonna put this under, okay. So this piece shows sine of A is unique. Right? This shows sine A is unique. And this next one shows cosine A is also unique. Okay, and this guy shows what? Shows tangent. Tangent of that angle is unique. So tangent is unique. And the next one shows cotangent A is unique. We have two more to show, right? Two more to show. Two more to show, those are R1 over Y1, R1 over X2, X1, and R2 over Y2. So these just, we already have sine that's unique, cosine is unique, and their ratios is formulated like this. So I'm going to make a row, I'm going to make a column, right? So on this side, if these two are the same, and I'm going to flip the side, right? So R1 over Y1 will be the same as R2, right? We just flip both sides. That's Y1, right? And these ratios are what? These ratios are cosecant. And therefore this shows the cosecant expressed by R1 over Y1, R2 over Y2, they're the same, okay? Therefore, this tell us, right? Cosecant A is unique. Cosecant A is unique. And this last one, of course, is going to tell us, right? We just flip both sides. We flip both sides of this equal proportions. So we get R1, X1 equals to R2, right? We're just flipping both sides over X2. Right? So we just flip both sides. So what does this indicate? This tells us that secant A is also unique. There you go. So we just have proved why it doesn't matter which point we choose, right? So in the definition, it doesn't matter which point we choose. Okay, and next, we're going to get to unit circle. Because it doesn't matter which point we choose on the terminal, we are going to choose points that's not only on terminal sides of the angle other than the origin, we also want to choose the points that are on the right on the unit circle, In the past lessons, we have constructed this. These numbers. We literally constructed them one by one, right? So let's recall what we have done. Okay, let's recall what we have done. From the definition, and after knowing that any point is okay on the terminal side of the angle other than the origin, we chosen the point to be on the unit circle, and we have constructed, right? So this is the trajectory we have covered, right? So we first studied if the terminal is right here, it's a special angle, and next we discuss the terminal is here, right? With reference angle pi over 6 and terminal here and terminal there. 4 cases we studied. And then we studied 45 degrees as reference angle. And this is a terminal. That is a terminal. And that is a terminal. All these cases we have studied. Pi over 3, right? Next one. Next one. Next one. So if you have not watched those lessons, please do. With this construction, we also have studied what if the terminal is here? Terminal is here. Terminal is there, right? Terminal is over there. 2 pi, and so on and so forth. It could be clockwise, right? It could be clockwise totally, right? It could be clockwise measurement of the angles, right? It could totally be clockwise or counterclockwise. Now, a new question arises. A new question arises. Remember this question you saw? Okay, I made a little graph about this situation. Right here. Okay. Right here. Do these points has a row on the unit circle? Right? So if I put, take the 4,3, for example, right? You guys should be pretty familiar with this example. And suppose 4,3 is a point on the unit circle, not on the unit circle, it's on the terminal side of the angle. And we have found, right? You have found it. You have found the following value. You have found the following value. Say we take sine, for example, right? We found that the r is equals to 5, right? And x equals to 4, y equals to 3, right? X equals to 4, y equals to 3. What is the sine value? Sine of that angle is equals to what? Y over r, right? Y over r. So that's a 3 over 5. No, 3 over 5, sorry, 3 over 5. And cosine of that angle is what? Is a 4 over 5. By definition, right? What is 3 over 5, 4 over 5? The 3 over 5, 4 over 5, what about these two numbers? Does these two numbers have a place on the unit circle? In other words, my question is, right? With the cosine equals to 4/5, sine equals to, for this pair, okay, 3/5. 3/5. Does this point has a place on the unit circle? Does this point have a place on unit circle? Apparently, this point is on, has a radius, this point is on unit circle, isn't it? So they should have a place. How do I know it is on unit circle? How do I know it is on unit circle? Well, if you take this x, take this as x, you take this as y, and you will find that if you square both, if you add the squares, right? 4/5 squared, wait. 4/5 squared plus 3/5 squared is going to equal to what? It's going to equal to 16/25 plus 9/25. And then this is going to equal to 25/25. 25/25. And 25/25 is 1. Okay, so this pair as 4/5 is the cosine value of a non-special angle, right? Non-special angle A, we don't know what it is, but we can find out, okay? Very soon, okay? If you have a calculator, get your calculator ready, okay? Maybe do the arc sign or something, okay? I want to get you guys to think about this, okay? So now, 4/5, 3/5 is on the unit circle. Where would it be? Where would it be? It's definitively have a point. It has a place there, okay? So let's find that place. Obviously, the sine ratio is 3/5, right? 3/5 is a 0.6. 3/5 is a 0.6. Okay, 3/5 is a 0.6. So all we have to do, of course, we're going to just estimate, right? 3/5 is 0.6, half is 0.5. So this point is going to be higher than pi/6 terminal, right? And the √2/2 is about 0.707. So this terminal for the angle A, which is non-special, is going to be somewhere here. Okay, maybe here. That's the terminal. Okay, so we know the terminal for pi/6, pi/4, pi/3, etc., etc. So this point also has a place on the unit circle. The point we're making here is that there's all these red numbers and blue numbers. And in between the red and blue of these special numbers, there are tons of other numbers that are in similar row, play similar role, okay? So I'm going to mark this point. Okay, hold on. Maybe the internet's a little slow, isn't it? Okay, so this point, okay, I'm gonna mark this point. This point can also be marked as red and blue, Okay, red and blue. And there's a comma in between. So what is the red number? The red number, of course, is in the same class of all the red numbers, which is going to be what? This red number is 4/5. Okay, so this is red. Okay, it is 4/5. And the blue number, what is the blue number? 3/5. Okay, 4/5, 3/5 is over here. And now we, of course, you guys did many cases in all 4 quadrants, right? How about -4/5 to 3/5? And you know where to mark it, right? It's probably somewhere here. Right? It's probably somewhere here. Probably somewhere here. You'll mark it as -4/5, 3/5, right? So this point will also have a place on the unit circle. And the 3rd quadrant, 4th quadrant. In fact, every non-special angles, they will have their terminal will have a place, they have a crossing with their terminal will cross the unit circle. Okay, and there's a place there. The question is, for this pair of ratio, what is that angle? What is this angle? It is certainly not pi over 6. It is not pi over 4. And how do we find it? How do we find it? Yes, how do we find it? And this is the role that arc sine or arc cosine can play. Okay, so this angle, okay, if it's measured from standard position counterclockwise, only up to here, this angle, okay, between, it's going to be arc sine 3/5. If you punch this in your calculator, you should get a degree or radian. Let's see what I get here. It's most likely radian. It's most likely it's radian. Okay. You see, this angle is 0.6435 approximately. And the arc length, we talked about arc length, didn't we? The arc length, okay, for this opening is this much. That's the arc length. That's the arc length. You can see the reason we study special angles is because we want to develop methods so that we can handle non-special angles. The creation of sine function, arc sine, cosine, arc cosine, we created these functions not for special angles only, because even for special angles, we already know their values, right? From sine to ratio and from ratio to sine, ratio to angle, we already know them. We don't need to create more things for them. We create these functions so that we can handle non-special cases. Okay, I hope that makes sense to you. And I hope this, take us back to the definition, okay? And of course, arc sine, right? In terms of arc sine goes, right? This is going to be where? The range of this number is going to be between negative pi over 2 to pi over 2. Right? So now if you look back, right, we go from definition of the trig functions ARD all the way to the graph of sine, arc sine, cosine, and arc cosine. In the whole design, we're still working on that stage set. So not only now we can handle special angles, we should also be able to handle non-special angles. Okay, and for non-special angles, what you do? You use a calculator. There are programs has been developed. Program has been developed scientifically to handle those cases. All right. I hope this helps our understanding. Okay, so every non-special terminal, they all have a place, they all have a red number and blue number corresponds to it. Okay. But anyway, without further ado, I think we're going to close this lesson and I will see you guys next time. Thank you for watching.